So welcome back to the Science and Technology NCERT course. In this, we have already started our chapter first, that is matter. And in this chapter, we have already studied what is matter. We said that anything that occupies space and it has some mass, that is matter. Then we said this matter is made up of tiny particles. And we studied the properties of these tiny particles. If you remember, we said they have kinetic energy. They keep on moving. Continuously they are moving. In solids, they move little bit in a slow manner. But in the liquid, they'll move in a faster manner. In the gaseous form, they'll move way faster. So such properties we have discussed. And we discussed three states of matter. We said there are total 5 states of matter. And out of that, we only discussed 3. That is solid, liquid and gas. Okay. This is what we have studied till now. Now moving forward, we'll continue with this states of matter point. And here we'll study what are the things or what are the factors that affect this states of matter. That simply means if I have something in the solid form. So for example, let's say I have taken gold or I have taken ice. Both of these are in solid form. Now, if I give it something, if I give it some extra temperature, what will happen? Will temperature affect them? The answer is yes. If I give temperature to gold or ice, you will see after some time they are in the solid form, but they will be converted into liquid form. So if you are heating ice, after some time ice will get converted into water. And if you keep on heating, what will happen? Even that water will start vaporizing. So it will be converted into gas form. Similarly, if you are taking gold and if you are giving heat to it, what will happen after some time? The gold will start melting. It will become liquid. So that simply means when we are changing temperature, there is something that is going to happen with the state of matter. Its state is going to change. So we can say if we are increasing the temperature, if the temperature is increased, it is higher. What exactly happens is the particles inside that matter will start moving faster. So if you remember, I said that in solids there are particles, but they are moving in a slow manner. In liquids, they are moving in a relatively fast manner. And in the gas form, they are moving in a way faster manner. Right? And interestingly, if you give more heat or more temperature to solids, the particles are in slow, they are moving very slow. They will start moving faster. And after a point of time, that solid thing will get converted into liquid thing. So ice will get converted into water. And there these particles are moving faster. This is happening because particles are moving faster. Similarly, if you do the same thing with the liquid, then the particles which are moving with fast speed, they will move in a way faster speed. So the point that I'm going to conclude over here is that temperature has a role to play in the state of matter. If you increase the temperature, the particles will move faster. And similarly, if you do the reverse thing, let's say I have taken something that is already in the gas form or liquid form. And now, if I reduce the temperature, so I have taken, let's say, water. I have some water, I've taken it, I have put it inside a refrigerator. So what is refrigerator doing? It is reducing the temperature. So if you reduce the temperature, this water will get converted into ice, that is liquid will become solid. That right? Why this is happening is because the particles are slowing down. In the water, in the liquid form, the particles are moving in a fast manner. But when you reduce the heat, when you reduce the temperature, the particles will slow down and relatively they will become rigid. Okay. So overall, we are concluding temperature is one of the major factors that is going to affect the state of a matter. Clear? Now, similar to temperature, there is some role played by pressure. Pressure has a role to play. We are saying if you are increasing the pressure, the particles will come closer. It's very obvious. You can just imagine, let's say there are 10 people standing over here, including me. Okay, but nobody's applying any pressure. So we are in the same room, but we are spread. Someone is at that corner, someone is at that corner. But now, if someone starts pushing them, let's say there are some people who started pushing them, so we will come closer. Similarly, when you apply pressure on something, the particles inside that matter will also start coming closer. And obviously, if you're reducing the pressure, if you're making it less, then particles will spread. They'll move away. This is obvious. Now, I'll give you an example. If you have ever heard about LPG, so at your home in the kitchen, you have one cylinder using which you're cooking your food. In that cylinder, we say there is LPG gas inside it, liquefied petroleum gas. This is the long form. The term that we are using is it's a gas. But if you check, it is there in a liquid form. So what we have exactly done, we have taken lot of gas that is there. We have compressed that gas. We have applied pressure on that gas. And then the particles of that gas came together, they came closer and they got converted into a liquid form. And that cylinder contains a gas in a liquid form because the particles have come closer. And obviously, if you again remember, solid, liquid, gas. We said in the gas, particles are spread. In the liquid, the particles are flowing, relatively spreaded, but not that much which are there in gas. In the solid, they will be very, very close. Right? So if you take example of LPG, or you can even take example of CNG, those students who are from Delhi, they know very well about CNG gas. So all these are gases whose particles we have compressed or pressurized. We have put pressure. Now from all of this, what I am trying to conclude is there are two major factors which affect the state of the matter. If state is solid, it can be made liquid or it can be made gas, or reverse also. That is possible by applying temperature or pressure. That is possible. Clear? Now this is the basic part we have understood. Now there is an advanced concept which you need to understand in this. We said if you just focus on the temperature part, when you are increasing temperature, the particles are speeded up, they are moving faster. But just because you have added temperature, that doesn't mean it will get converted from solid to liquid. There is some interesting phenomena that takes place, or there is something that we need to understand which we call as latent heat. So actually, this latent heat changes the state of the matter. So what happens, see, we have something in solid form. Okay, again, for example, ice. And now we are saying after applying some temperature or increasing the temperature, it will get converted into liquid, but that doesn't really happen. When you apply temperature, when you are increasing temperature, let's say right now water is at 30 degree Celsius temperature. We made it 50, we made it 60 degree, we made it 70 degree, right? We are increasing the temperature. Or let's say we have taken ice, which is at 0 degree temperature, or minus we can say. But you are increasing the temperature, the particles are moving. But when this change has to take place, that suddenly at one point, the solid will suddenly change into liquid. Now this happens at 0 degree. As soon as something is turning from 0 degree solid to liquid, interestingly, the temperature is not increasing. I'll repeat. We have taken something, we have started increasing the temperature. So let's say this thing earlier had 5 degrees Celsius temperature. Okay, we increased the temperature, we made it 10 degrees Celsius, then we made it 20 degrees Celsius, or whatever. So the temperature of this matter has got increased, and continuously we are heating. But there will come a stage when its temperature will not increase. It will stop. Rather than increasing the temperature, rather than the particles moving because of this heat, the same heat energy which we are increasing temperature means we are giving heat energy to it. That energy is utilized for particles to move faster. But at a point of time, this energy will not be used for these particles to move faster. Rather, this energy will be used to convert or change the entire state of the matter. That means a solid will be converted into liquid, and for that whatever heat is required, that heat is here used, and that heat is called as latent heat. I know many will get confused, so I'll give you a brief recap of all of that whatever I have discussed. Simply, when you increase temperature, the particles inside the material will start moving faster because they are getting energy, heat energy, so they will move faster. Simply, if I start feeding you, you have eaten something, then you will run faster. If I give you more food, you'll run faster. So as much energy you are getting, you are moving faster. Now the point is, this will keep on happening, but there will be a time when whatever heat energy that is coming, that will not be used for particles to move faster. So at one point of time, this temperature which is continuously increasing, this will not happen. Even if you give energy, even if you are giving heat to this matter, its temperature will not increase. It will remain the same, but that energy will be used for something else. And what is that something else? To change the state of that matter. So from solid it will be made liquid, or from liquid it will be made gas. So I'll give you the best example of water. See, at room temperature or normal temperature, water is in liquid form. So let's say right now water is at 30-degree temperatures, just for the assumption purpose. I have started giving this water some heat. Continuously I am giving heat. After some time I saw the temperature of the water is 50-degree. After some time it has become 70 degrees Celsius. After some time it became 90 degrees Celsius. And after some time it became 100 degrees Celsius. Now I am continuously giving heat. Temperature is increasing for water. But interestingly, after 100 degrees Celsius, the temperature is not increasing. It's not becoming 101 degrees Celsius. It is not becoming. Rather, at 100 degrees Celsius, it remained constant, and suddenly the water started becoming vapor, or it started becoming gas. So I'm saying there will be a point where the temperature will stop increasing, temperature will not change, and whatever heat energy is coming, that will be used to change the state of the matter. Water will become vapor. Now I hope you got it. And this heat which is used over here to change the state of matter, that heat is termed by scientists as latent heat. Clear? So if we read in simple terms, latent heat is an energy absorbed or released during a phase change. Now don't look at this released part. I'll discuss that in the later slides. Right now just look at the energy that is absorbed. So from water to gas, we are saying some energy is being absorbed during a phase change. That means from solid to liquid, whatever this conversion or this transition has to take place, there this energy is being absorbed, and there will be no change in the temperature. But what is exactly happening is the intermolecular bond is breaking. So if you remember, in the first lecture I said, in the solids, the bond between particles is very strong, right? In the liquids it is relatively weaker, and that's why they are flowing. And in the gas it is way weaker, and that's why the gas is spreading, right? Now when you are increasing temperature, the particles inside, they have a very strong bond. Slowly, the particles have started moving faster. Earlier they were moving slow, now they are moving faster. But their bond is there, that strong bond is there. When a point comes wherein that phase change is happening, that means the latent heat is being absorbed. At that point of time, what will happen is this strong bond will be broken. Now they have bond, we have said we have broken that bond. And after that, when the bond is broken, then actually this solid will become liquid, or a liquid will become gas when the bond breaks. Got it? So overall, this is how this state of matter is changing, and the heat that is being absorbed over here is called latent heat. Okay, now we'll understand it in better details, or rather we can say latent heat, how it is taking place, you'll understand with examples. So I'll take the first example of latent heat of fusion. Okay, don't think a lot about this fusion as such. Okay, simply understand melting. What happens in melting? We have taken something, we have taken gold, we have started giving it some heat. Its temperature is increasing, it became 100 degree, 200, 500, 600. Now the temperature became 1064 degrees Celsius, and at this point its temperature started its temperature is not changing at all. Now what is happening? Its state is changing from solid to liquid. Why? Because now its bond, the molecules or the particles that are there, their bond is breaking up, and so it will convert into liquid, and this process is called melting. And the heat, the latent heat that is being used over here in this phase is called as latent heat of fusion. Okay, it's just a name that you can remember. Now let's say, now here earlier we discussed solid getting converted into liquid. Here we are saying liquid getting converted into gas. So if you are taking water, heating it up, it will get converted into vapor. So it is, this process is called as vaporization, and that's why the heat that is being used over here, that is at 100 degrees Celsius temperature, the water will convert into gas, and to convert it, they have to break the bond that is there between the particles, and to break that bond, whatever energy that is being absorbed, that energy is called as latent heat of vaporization. So same thing will happen after 100 degrees Celsius. It will not become 101, 102, rather whatever energy is there, that will be used to break that intermolecular bond. Okay, so what we say, this 100 degrees Celsius is the boiling point of water. At this point, water starts boiling and it gets converted into gaseous form. And this point could be different for different things. So for alcohol, it is 78 degrees Celsius. At 78 degrees Celsius, it will start becoming gas. Okay, so this is called boiling point. Okay, solid to liquid is clear. Liquid to gas is clear. Now let's go reverse. Gas to liquid, reverse stuff. So we have taken some gas. So gas, you can imagine anything, oxygen, carbon dioxide, any gas. Now what we are doing is we are reducing the temperature. We are reducing temperature. Now when you reduce temperature, earlier we were increasing temperature. That means what we were doing, we were giving it heat. When we give heat, when something absorbs heat, that means their temperature will increase. Here we are reducing temperature. That means that material is giving away its heat. So when you take the heat out, that is what we say as temperature is being reduced. Okay. Now when you are reducing temperature of a gas, what will happen is at a point of time, it will get converted from gas to liquid. Okay. Or from liquid, it can get converted into solids. This will happen for sure, and this process is called as condensation. When gas converts into liquid, it is called as condensation, and that's why at the point where this state of matter is changing, it's called as the heat that is being released over here is called as latent heat of condensation. Please understand, I'm using the term the latent heat is being released and not being absorbed. If you remember in the melting, what we said, we are giving it heat, so it's absorbing heat. But here we are taking away the heat. We are taking away the heat. So heat is not absorbed over here, rather we are taking away. Okay, so this heat that we are taking away from this matter to change its state from gas to liquid, then it is called as latent heat of condensation. And in case of liquid to solid conversion, if we are converting from liquid to solid, similarly putting water in the refrigerator, making it ice, right? Here what is happening, this is happening at 0 degrees Celsius. So if we have taken water which is at 30 degrees Celsius, we have to reduce the temperature, reducing. That means we are taking away the heat inside it. So when you are taking the heat out, it becomes 0 degrees Celsius, and after this you can't take away the heat. Rather, it will first get converted into a solid form. It will become, that is, it will become ice. Okay, and the heat energy that we are releasing, that we are taking out, that is called as latent heat of solidification. These are just terms that you should know. Okay, now basically, before we talk about other things, now just understand, if we have something in solid form, if we give it heat, it will remain solid only, but its temperature will increase. But after a point of time, its temperature will not increase. It will take all that heat to change the state from solid to liquid, and the heat that will be taken or absorbed is latent heat of fusion. Similar thing will happen in case of liquid, and here the liquid will remain liquid, but its temperature will increase. After a point of time, temperature will not increase. The heat will be used to convert it into a gas form. So this is this heat which is being absorbed is called latent heat of vaporization. Got it? And now this is the mechanism we understood in one direction. The reverse can also happen. Gas can become liquid, and the heat that is released over here, latent heat of condensation. Liquid can become solid. The heat that is released over here is latent heat of solidification, or you can call it latent heat of fusion. Same. Now, this directional thing we understood, solid to liquid, liquid to gas. This also we understood, gas to liquid, liquid to solid. Now there is something interesting, that a solid can directly convert into gas. Without becoming liquid, it can directly become gas. Or a gas can become solid directly without becoming liquid. That means a direct transition. That is also possible. So, first thing, if you have taken solid thing, we are saying liquid will not happen. Directly it will become gas. This direct stuff is possible. And this process is called as sublimation. This process, what we are calling it as sublimation. Now, what is happening? We are giving heat to the solid, and we said that after a point of time it will become liquid. But if you give it a lot of heat, a lot of heat, in that case it will skip this liquid state altogether, and it will directly become gas. And it is not the case that this will happen with everything. So there will be some substances in which this direct transition will happen. In some things it will not happen. For example, if you have taken ice form, if you have taken ice, it will first become water and later on it will become gas form. But if you take this ice, this one, we call it as dry ice. So this dry ice is very interesting. If you give it more temperature, it doesn't become liquid. It directly becomes gas. And this ice is different from the ice that we use in our home. The ice we have is nothing but water in solid form. We call it H2O, right? It is made up of hydrogen and oxygen. But this dry ice, this one is a different one. It is made up of carbon dioxide. It is made up of carbon dioxide. So as soon as you give it heat, it won't become liquid, it directly becomes gas. And this process is called as sublimation. And here, to change the state from solid to gas, whatever energy, heat energy that is being absorbed, that energy is called latent heat of sublimation. Okay, you should know the term only. Similarly, reverse is possible, I said. The gas can directly become liquid, directly become solid, and this liquid phase will completely be skipped. So this is also possible. So best example is the frost that gets formed on the windows. If you have seen people living in Kashmir or in the winters, many a times the frost gets formed on your windows or in the shield. This happens. So this is the best example. So the frost is nothing but something in a gaseous form and it directly becomes solid. So this takes place. Okay, it is called as deposition. Just a terminology, deposition. And obviously the heat that will be released over here, that will be called latent heat of deposition. So now if I have to summarize whatever I have said, all these transitions or interconversion of state of matter is possible. This one will get converted into this one will get converted into this one can directly get converted into this, and reverse is also possible. Okay, but if you give heat, particles will move faster. After a point of time, the heat will be used for changing the state. That will be called a latent heat. Okay, this is the basic idea that you should have. Clear? Good. Now 10 seconds break so that you can recall whatever we have studied. After 10 seconds, we will move further with other states of matter. 10 seconds. Done? Now see, whatever we discussed till now is about the state of matter. And we said there are total 5 states of matter, out of which we have only discussed 3. And for the basic understanding, only these 3 are important for you. But the advanced studies have claimed that there are 2 more states of matter. Although we might not observe it, but they are there. One of them is called as plasma state. And the other one is called as Bose-Einstein condensate. Okay, we'll understand why this name Bose-Einstein condensate is there. But look at this, if something is in solid form, if we increase the temperature, it is becoming liquid. If we increase the temperature of liquid, it is becoming gas. That means increasing temperature means what? We are giving it heat. We are adding heat energy. Simply, we are giving it more energy, more energy. So giving energy, if more energy is given, solid will become liquid. If more energy is given, liquid will become gas. But what will happen with gas? If gas is given hell lot of energy, hell lot of heat energy is being given to gas. So after a point of time, it will become plasma. This is something that is going to happen when there is immense energy that is being given to gas. So it will turn into something very different, and that is plasma. And similarly, if we are reducing temperature, gas is becoming liquid. If we are freezing liquid, it is becoming solid. But if you can imagine what will happen with solid if its temperature is reduced a lot, we can't even imagine how much it is being reduced. At that point of time, it will get converted into Bose-Einstein condensate. This is the state of matter. Now, let's take each one of them. So first, plasma. That is the state which comes after gaseous form. When we give more energy to the gas, then it becomes plasma. To imagine plasma, you can look at sun. You look at sun. Can you imagine the temperature that is there at the surface of the sun or at the core of the sun? You can't imagine. Hardly we can imagine temperature that is beyond 100 degree. Have you ever touched water which is at 100 degrees Celsius? Your hand will start burning if you do that. But at the sun, the temperature is in thousands, 2000, 3000, 5000 degrees Celsius. Can you imagine that? At that temperature, something will not remain gas. When you're looking at this is the image of the sun. If you are saying this, all this thing is not in gas form, not in liquid form, not in solid form. Rather, it is in plasma state. So, what is plasma state? It is a state of matter when it has very, very high energy. We have given lot of temperature, lot of heat energy. So energy is very high over here. So what happens, whatever particles that are there in a gas, there are particles in the gas. When heat is being given, these particles will start becoming charged particles. A charge is developed. So for now, you just understand charged particle means some kind of electrical conductivity will be there. If you have heard about proton, electron, we'll study that in detail when we start studying atoms, molecules, ions. But for now, please understand that the gas particles, when they are given lot of heat beyond their capacity, they become plasma and they become charged particles. They can now conduct electricity. So some particles will have positive charge, some particles will have negative charge, and they can conduct electricity now. Not just they can conduct electricity, but if there is some kind of electricity outside, these particles will get affected because of that electricity. So let's say some electricity is flowing over here. So they generate some electrical field. So that field will also affect these particles now. So whether it is electrical field or magnetic field, although these are very advanced concepts which we will study further, magnetism and all, electricity and all. But for now, please understand, plasma is a state wherein the particles become charged particles. They will conduct electricity. They will respond to any electric or magnetic field. And they will also emit light. Why they are emitting light? Because the particles are highly energetic. In gas, they were already moving very faster. Now they have so much energy that we can't energy how much faster they are moving. They'll start colliding with each other with a very high speed, because of which this light is generated because of these collision of these particles. So anything that is in plasma state will have high light that is being emitted out of it. Getting the point? Good. So this is plasma state. Again, after the gas state, the plasma state is coming into picture. Clear? Now the state which comes before this, or if we reduce the temperature, if we take away the heat, see, when we took gas and if we taken out the heat or energy out of it, how will you feel if your energy is taken out? You will feel lethargic, you don't want to do anything. Similarly, gas would not want to run away, the particles will not move a lot, they'll become liquid. If we have taken all the energy from liquid, they'll become solid. Always substantial energy is taking out, the particles will become very much dull, and they'll remain at one place, they'll become solid. What if the energy of the particles in the solid is also taken out? That means we have reduced the temperature, we have taken all the heat that is there in these solids. So we have reduced their temperature to absolute zero. Can you imagine absolute zero? I'm not talking about 0 degrees Celsius. I'm talking about absolute zero temperature. That means below this there is no temperature. See, if something is at 5 degrees Celsius, we can reduce it. We can reduce it, make it 0 degrees Celsius. We can even go minus 15 degrees Celsius. This is possible, right? But at a point, after a point, there will be this point wherein there won't be any reduction of temperature. We are calling this as absolute zero. You can't freeze or you can't reduce the temperature beyond this point. This point is called as absolute zero, and rather than using Celsius, we make use of Kelvin for this. So 0 Kelvin is absolute zero, or in Celsius form it is minus 273.15 degrees Celsius. So there is no temperature after minus 2.73 273 degrees Celsius. There is no temperature below this. Just imagine you have reduced the temperature of a solid thing to this absolute zero. What will happen? We already said solid thing has particles inside it, but they have very low energy. They are moving, but they are very slow. That's why they are in solid form. This all thing is in solid form because the particles inside are not moving a lot. They have very low energy, low kinetic energy. But now you have taken out all the energy, so particles will completely stop moving. They will not move at all. So there were thousands and lakhs of particles. Nobody is moving. So if nobody is moving, what will happen? Now all these particles, they won't behave like they are different particles. They'll become one. I said there were 1,000 particles earlier. They were moving. Now they have come together. They are not moving at all. So now we see just one particle. So their behavior will become like a super atom. Already there were multiple atoms. Now all came together and now they are like we are one. Super atom behavior. This is the state where we call it as Bose-Einstein condensate state. It is not solid now. It is now Bose-Einstein condensate. And why we have named it Bose-Einstein is because in the year 1925, Albert Einstein and an Indian physicist or Indian scientist, Satyendranath Bose, both of them proposed the idea of Bose-Einstein condensate. That means before 1925, nobody knew that there is something called this state which is possible beyond solid form. That's why we call it Bose-Einstein condensate or BEC in short. Okay. So to briefly revise, solid, liquid, gas. If energy is given, if more energy is given to solids, it will become liquid. Then it will become gas. If more energy is given, it will become plasma. And if energy is being reduced, it will go in this direction. After solids, the Bose-Einstein condensate is possible. Okay. We can't see. Obviously, this is the form which we can't see with our eyes. Okay, if something is in Bose-Einstein condensate, we can't see using our naked eyes. Clear? I hope it is clear. So we are moving forward. Now, all the 5 states of matter are clear to us. So we understood what is matter, the tiny particles inside it, and the states of matter. This topic is very much clear now. Now we are moving ahead with classification of matter. Now we are taking all the matter that is there and we are classifying it into different things. So let's say you students, some are in 2026 batch, some are in 2027 batch. We have classified. These are different batches. Similarly, we are classifying matter. So if we take any matter and we classify them into just 2 things. One will be called as a pure substance. Other one will be called as a mixture. And we'll understand with the example. Look at the air. Although you can't see air, but you can feel it, right? Whatever air we have, this air includes so many gases. We have oxygen, we have carbon dioxide, let's say we have some water vapor or H2O in vapor form in it, we have nitrogen, and we have so many other gases. That means air is something that is made up of so many gases. So if I talk about just air, if I talk about just air is a matter, it occupies space, it has some mass, but air is a mixture. Air is a mixture. I can categorize it as a mixture because it is mixture of so many other things. It has oxygen, carbon dioxide, so many things inside it. And all these things are not mixed. There is oxygen separately available, there is carbon dioxide separately available, which is over here, right? We take oxygen, we remove carbon dioxide. There is no problem. There is no problem. So air is a mixture. But if I simply talk about the oxygen over here, then I say this oxygen is a pure substance that we have. Or if you take carbon dioxide, then it's a pure substance that is available in the air. So all these individually, they are pure substance. And air is a mixture. Now if I read the definition, a mixture is having two or more substances mixed together. And pure substance, matter that has a fixed chemical composition and distinct properties. So when we said we have oxygen, this is the chemical formula of oxygen. Or let's say we have taken carbon dioxide, this is the chemical composition. The composition is very clear. There will be one carbon, two oxygens, and it will become carbon dioxide. There will be two or oxygen atoms and it will be called oxygen. Or if you are taking water vapor, okay, H2O vapor, so two hydrogen, one oxygen, so fixed combination is there. It could be one single atom or two different things, but they will be together. It will be called a pure substance. Whereas if there are multiple things that are together, multiple substances that are together, it will be called mixture. Clear? Basic classification is clear. But now, because now we'll move on with advanced concept. This is basic classification. We said matter is classified into pure substance and mixture. Pure substance and mixture. Now we are saying we can classify these two also. Pure substance can be classified into two things. One is elements, other one is compounds. Mixtures can be classified into homogeneous mixtures and heterogeneous mixtures. Even this heterogeneous can also be classified into two different things. Okay, so each one we will understand one after the other. First, pure substance. First we'll discuss pure substance. In this we have two classifications, elements and compounds. Now just take the example of oxygen and carbon dioxide. From the example itself you will understand. If I just take oxygen, then it is called as element. See, both of these are pure substances. They are not mixtures at all. Air is a mixture. Both of them individually, they are pure substances. But if I take oxygen only, O2, we are calling it element, O2, or rather if I am taking only O out of it, we are not even considering that 2 aspect. O, oxygen over here is an element. Carbon dioxide, when I am looking at it, you see, carbon dioxide includes carbon as well as oxygen. Carbon in itself is an element. Oxygen in itself is an element. But when the two came together, they have a fixed chemical formula that there should be one carbon, there should be two oxygens, then we'll call it carbon dioxide. So, such a thing will be called as a compound. Okay? So, let's see their definition. Elements, they cannot be broken down to simpler substances, whereas compounds have fixed composition and can be broken down into elements by chemical or electrochemical reactions. We'll understand that chemical reaction what it is later on. Right now simply, if I have carbon dioxide, can I break it into smaller things or smaller substances? Yes, I can separate carbon, I can separate oxygen. Is it possible? It is possible. So compounds are having fixed composition, but they can be broken down into different elements. It is possible. But in case of elements, if I have only taken carbon, if I have taken only oxygen, only, just take one only, I have taken carbon only. Can you break it down into other elements or smaller elements, simpler elements? No, it is carbon. It will remain carbon. So carbon will remain element. So examples are given: copper, oxygen, iron, hydrogen, mercury. All these are elements. Whereas water is made up of H2O. There will be two hydrogen atoms. There will be one oxygen atom. If all this is there, then we call it as water. So water is a compound. It's not element. Hydrogen is an element. Oxygen is an element. Then methane, sugar, salt are these are all these compounds. Clear? Now, all these are pure substances. So if you understood, then we will move ahead with the mixtures part. Okay. Let me check if we have slides. Yes, we have slides for elements. We have slides for mixtures also. Okay. Before moving ahead, here only we'll see. Now we are talking about mixture. Mixture means something where the composition is not fixed. So if you're looking at air, is it like only nitrogen should be there and there should be uh, N2 and O? If this is the combination, we don't call it mixture as such. This will be a compound. Mixture will be something where the fixed composition is not there. It could be anything. Now this mixture is of two types. One is homogeneous, other one is heterogeneous. Let's say I have taken water. In this water I added sugar. In the water I added some sugar. So after some time that sugar gets dissolved completely in the water. Are you able to see sugar? No, but it is there, you know. Now if you look at this water which is having sugar, so we call it sugar water, let's say. It's a mixture. It's a mixture and sugar has completely got dissolved into this water, right? Now this solution we call as homogeneous one. Homogeneous. Whereas if you take the example of oil and water, we had some water, we add some oil into it. Now you do whatever you want to, but the oil and water will not mix. Oil is not going to dissolve inside water completely as such. So whatever you do, after some time what you will see, some layer of oil will be there, some layer of water will be there. Now this is a heterogeneous composition or heterogeneous mixture. Although we'll understand in detail, but just for brief understanding, we are taking different substances, we are taking different elements, different compounds. You see, you can take some elements, some compounds, mix it, it will become a mixture. But that mixture will be of different types. Clear? This is basic. Okay. Now, beyond basics, if we have to talk about each and every aspect of it. So, pure substances, elements, if we talk about elements, single elements. So first of all, they are composed of only one type of atom. So even if we have taken hydrogen, we have taken oxygen, if we have taken carbon, these are made up of only one type of atom, right? There is no mixture, there is no other element or other atom coming into picture. There is only hydrogen atom. That's why we are calling it element. Now these can exist in different forms. Element can exist in different forms. Now let's say I have taken gold. Gold is also an element. It is there in solid form. You have taken carbon, it is in gas form. Oxygen is in gas form. Something can remain even in liquid form. Okay, all this is possible, right? And these elements are further classified, or their types can be said as metals, non-metals and metalloids. Now this part we'll discuss in later chapters. Okay, but we can classify them when we study that periodic table. I'll show you some are metals, some are non-metals, some are metalloids, and we'll understand the difference also. For example, if you have taken gold, if you have taken iron, if you have taken copper, we call them, they are metals. But if you take oxygen, sulfur, we call them non-metals. And like silicon, boron, they are metalloids. We'll understand their property in detail later on. But I hope elements is clear. This part is clear. Second is compounds like carbon dioxide, hydrogen, H2O, etc. So compounds are combination of elements. Two or more elements, they are chemically combined in a fixed ratio. Their ratio is very fixed. We said if you take H2O, it is very clear. If you make it HO2, then it will not be water. Their chemical composition is very clear. We need two hydrogen atom only. We need one oxygen atom only. And this is in very fixed form. This will be called a compound. This cannot be. Okay, this means this will not be water as such. And we can break it down chemically. So we can do some chemical reactions on water. After that reaction, we can take hydrogen out and we can take oxygen out. This is possible. Chemically we can change it. Such a thing is called as compound. We took the example of H2O. We can take the example of salt also. Salt is made up of sodium, that is Na, and chlorine, Cl. One atom of sodium, one atom of chlorine. But they are there. If you take two atoms of Na and three atoms of chlorine, it will not be your salt. Whatever salt you eat now, that it will not be there. It will be something different. So there will be a fixed formula, and they can be broken down into separate things or separate elements. Na can be taken out, Cl can be taken out. These are compounds. Again, let's get back. Elements is clear, compounds is clear. Now mixtures. Mixtures. These mixtures will be of three different types, which are major things we can say, or I can show you here only directly. The first type is a homogeneous mixture, or we call it as solution. So we said we took water and we added salt or sugar into it. When you added salt into water, it got dissolved. So water was in more quantity, salt was in less quantity, we added into it. Okay, it got dissolved into it. Now here we use two terms. One is solute and other one is solvent. So whatever thing we have taken, let's say we took water which was in large quantity. Anything that is in large quantity or anything that we have taken, that is called as solvent. And anything that we are adding into this solvent is called as solute. So here salt that we are adding is a solute. Now this solute, what it will do? It will try to dissolve in the solvent. Salt will dissolve in the water. Now see, there is a limit till which you can add salt into something. Salt or sugar or whatever. You have taken some water. Let's say this much water we have taken. We are adding sugar into it. You add, you stir, and it will get dissolved. I started adding and I'm just continuing that process. After a point of time, you can't add more water into it. Means even if you add, the sugar will not dissolve into it. So we say that there is some limit. And if that limit is already crossed, Let's say in this much water you can add 200 grams of sugar and it will get dissolved. But if you add 500 grams or let's say 1 kg of sugar in it, it will not dissolve. Only 200 grams will dissolve. Remaining 800 grams will not dissolve. Why it is not dissolving? Because you have crossed that limit. When the limit is completed, that means when we added 200 grams of sugar, the limit of that solvent got completed. We call that state as a saturated state. So when we call it, it's a solution wherein we have added sugar into water, it has got saturated. That means that limit is crossed now. Now you can't add any more thing in this. You can't dissolve anything more in this. It is a saturated solution. Okay? But if you haven't crossed the limit, till that time, it's an unsaturated solution. So you can add. So right now this water that I have in this bottle, it's an unsaturated solution. I can add salt into it. I can add sugar into it. It will get dissolved for sure. But if it is already saturated, if I add, the sugar will remain over here. I can see the sugar. It will not dissolve. I hope it is clear now. Okay. So such a thing is called as a solution, and there are some properties of a solution that you should know. One thing, it will be very much transparent and the particles will not be visible. You added salt or you added sugar, you mixed it well, it got dissolved. Do you see sugar now? You don't see sugar. You don't see the particles of sugar. You don't see. So water remains transparent as it was, even when you are dissolving it, even when it is a solution. Second, it is very stable and you can't separate these particles. You added sugar. Now can you take sugar out of it? No. Can you take all the particles out? It's difficult. You can do it if you want to, but that's very tough to do. That means it's a very stable thing. Do you see? Means if you have dissolved sugar into the water, kept this water as it is for let's say 2 hours, 10 hours, 15 hours, does it happen after some time the sugar will come down and you can see it at the bottom? No, it has got dissolved. It will not come down or anything like that. So it's a very stable kind of solution. Now here, the particles which are dissolved over here or the particles of this solution, their size is very less. It's somewhere around 1 nanometer. So what happens is, if you try to pass on light, let's say in a glass of water, you have added sugar and all, and in this from this glass, if you're trying to pass on light from one side to the other, it will pass. It will pass, but this light will not scatter. Scattering means, we'll understand scattering of light when we study the topic of light. But if there are any particles in between, then light will change its direction little bit. We call it scattering of light. That will not happen over here. Okay, you don't need to remember this part. You'll understand it when we study light. So don't worry about this part for now. Just understand what is a solution. Okay, it's a mixture with these kinds of properties, or you can remember just this example. Okay, now there is second type of mixture which we call as suspension. Okay, see, there is one mixture that is homogeneous, other one is heterogeneous. So this solution was a homogeneous one, but here we are talking about heterogeneous. So you'll understand again with example. Earlier we added salt into water. It got mixed completely. Now I am adding some sand in the water. Some sand. What will happen? Will it get mixed even after you stirring it well? It will not mix. You do whatever you want to. You are shaking that bottle, you do whatever. This sand is not going to get dissolved in the water. So such a solution we are calling, it's not a solution, we call it suspension. We call these particles of sand are suspended in the water. They are not going to get dissolved, they will remain suspended. So let's say I've taken this bottle, I have this water inside it, I've added some sand into it, and I'm shaking it really well. So for some time, I will see some particles are here, some particles are here, some particles are here. It will be there. But if I keep it as it is over here for let's say 2 minutes, what will happen? All the particles that are there over here in the water, they will come down at the bottom. You'll see it over here. And you do whatever, they are not going to dissolve. Such is the property of suspension mixture or a heterogeneous mixture. Particles are suspended. Now, why this is happening or what are the properties? First of all, the particle size is very large. It is 1000 nanometers. Okay, particle size, sand's particle size is very large over here. They are settling over time, and even you can filter it out. You could not take sugar out of water, but here you can easily take that sand out of water just by using a filter. That is possible. And all these particles are very, very large, and that's why they are visible to us. We can see these particles. Okay, we could not see the particles of sugar which are there inside water, but we can see the sand particles very clearly. And because there are these large particles are there, when you try to push light in it, the light will scatter now. It will not just go like this because there is a large particle over here. The light might change its direction little bit. This is suspension. Okay, sand particles are suspended in water. Third one is colloidal. Now this is something in between solution and suspension. So what we do is we take the example of milk. Just look at milk. If you look at milk, we say milk is nothing but something which is made up of water. It has water as well as some other substances into it. Or if you don't like milk, you can take the example of blood. Blood is made up of many things. It includes plasma, it includes different cells, all of these things are there. Now, when you look at these things, we don't call them solution, we don't call them suspension as such, we rather call them colloid. Now, what is a colloid? There are some particles inside milk. They are not so small and they are not very large. They are in between. So their size is 1 nanometer to 1000 nanometer. Now, can you see those particles using your eyes? So you could see the sand particles you could see, but you couldn't see sugar particles. They were very small. But in case of these colloidal solution like milk, through your eyes you can't see those small particles, but if you use microscope, ultra microscope, you can see those particles of milk or you can see the particles of blood. But if I take that sugar water example, even if you use any ultra microscope, you can't see those particles. They are very small, right? Now, because of this nature, we see this solution as bit cloudy. And see this, even if you have taken milk, there are particles inside it. They are mixed in such a manner that they will not settle down. So interestingly, they don't settle down, they don't come at the bottom, they will remain inside it. But it's not like sugar water. See the difference. When you will get confused. Or I'll take the example over here. Let's say these are good examples. We have taken milk and we have added some cornflakes. Okay, or we can add sugar. Cornflakes would not be a better example. We have added sugar in the water. Particles got dissolved. They are not coming at the bottom. Even if you have put this water as it is, it will remain. No particle will come down, settle down as such. Instead of sugar, if we are adding sand, then the particles are coming down. But instead of that, we have taken milk or blood like solution. The particles are not coming down. Okay, such a solution is colloidal. And milk is a colloidal solution. Milk is not a solution, milk is not suspension, milk is a mixture which we call as colloidal solution. Okay. Now there is something called Tyndall effect which is mentioned, although you don't need to remember all these things, but just a brief idea that here particles are there. They are very small, but still scattering of light will happen. In the first example of solution, the particles were very small, right? So no scattering was taking place. In the second example, scattering was taking place because particles were very large, and in large particles it will happen. In this colloidal solutions, they are neither very small, they are nor very large, they are in between. So here also scattering will take place to some extent. It is called as Tyndall effect. The name is given over here. And interestingly, it is very hard to separate the particles. So if you take milk and you say that I'm going to separate the particles of milk, it's very difficult. Same with the blood. To if you want to take out plasma out from the blood, it's difficult. It's very, very hard. Okay. So this is all you need to know. So although we have discussed in detail, but you just need to understand basic part. Basic is important. That there is something called matter. It has different states. We can classify them into pure substance and mixture. Pure substance then can be classified into elements and compounds, and these are more important rather than these mixtures and all. This part is the most important, so focus on this part. And second is homogeneous and heterogeneous mixture. Heterogeneous will further include suspension, colloidal. Okay, so this is all for today. In the next lecture we'll move ahead. Okay.